In this video, we are going to talk about how to find the domain of functions. Now, for simplicity's sake, I've outlined the possible functions you might need to find a domain for. So I'll leave a link to the descriptions for the examples relating to this, okay? So you have polynomials, traditional polynomials. You have polynomials with roots. You have fractions, and then you have fractions with roots. So let's get into the video. Okay, so for our first example, we have x squared minus 5x plus 6. So if you are told to find the domain of this function. Now, one of the things to understand what domain is simply the numbers you can impute to a function that will give you a defined value. Okay, so for this function, you can impute any number into this function. So the domain of polynomials is often written as real numbers or the numbers from negative infinity to positive infinity. So it's either written as all real numbers or the numbers from negative infinity to positive infinity. What about, let's say we have a function of f of x, and then we have x plus 5. What is the domain of this function? So the domain of this function can also still be written as, because you can impute all values into this function and it should still be defined. So the domain of this function can be written as, the domain can be said to be equal to all real numbers or all numbers from negative infinity to positive infinity. So anytime you have a polynomial and you are looking for the domain is often all real number or this. So let's quickly get into the other set of questions. So for polynomials, there are polynomials with roots, okay? So once you have a polynomial with roots, the domain will change from all real numbers to another form. So before you start solving problems that relate to polynomial with roots, you need to realize the fact that for square roots of numbers, you cannot have numbers that are less than 0, okay? So every number you have to have under a square root has to be greater than or equal to 0. So the idea behind this is that it's going to affect the domain of our function. For this function to remain defined, this value inside here, x plus 5 would have to be greater than or equal to 0. Okay? So from here, I'm going to pick point of interest. Okay? So I'll be saying x is equal to minus 5 going to the other side, so negative 5. Why did I change the inequality sign to equality sign? Because I wanted to get a number line, okay? So every time I will change this to an equal to sign. I wanted to get the point of the number line, okay? So this is our number line, and then we have negative infinity, and then somewhere between that we have minus 5, and then somewhere to the right we have a positive infinity. So on this number line, on this point, I can have an open point or a closed point, but whether I have an open point or a closed point will depend on my inequality. Okay, so my inequality is greater than or equal to. So for greater than or equal to signs or less than or equal to signs, this point will be a closed point, meaning that this point includes minus 5. So this means that I'll be checking a number from minus 5 to positive infinity. Okay, so from minus 5 to positive infinity, let's say we pick a number 1. So if you plug 1 into this function of x plus 5 greater than or equal to 0, so 1 plus 5 is 6. and that is greater than or equal to 0. So we have a positive number here. So we are going to write this positive here. All numbers here will give you a positive number, and it's to satisfy this inequality. So from -5 to -infinity, we need to pick a number there. Let's say -6. So if you pick -6 here, -6 minus 5 is -6 plus 5 is -1. So we have a negative number here, and that negative number would not satisfy this inequality. So negative here. So the domain of my function will now be for numbers from here upwards. Okay, so the domain of my function is equal to a closed point. Okay, closed point is -5 and then up to positive infinity. So I want to bring to your notice the fact of this square bracket and this bracket. So anytime you have this bracket, it means that the point is a closed point or has a greater than or equal to or less than or equal to sign. For this bracket, it means that you have a greater than sign or a less than sign, and this is an open point sign. So let's pick another example for polynomial with roots. So for our second example, let's say we have m is a function of x and it is equal to the square root of x squared minus 6x. So I'd like you to pause the video and try to solve this one yourself. Okay, so like we did before, our main focus will be the number inside of the square root. So we need to make sure that x squared minus 6x is greater than or equal to 0. So from here we can factorize. Factorizing here would be simply saying x open bracket x minus 6 greater than or equal to 0. So we knew that to pick our points that we'll place on our number line, we have x is equal to 0 or x minus 6 is equal to 0. So x minus 6 equals to 0. So x is equal to 6 basically. So x is equal to 0 and 6. So on our number line, the points that of interest to us is 0 and 6. And then to the left of 0, you have negative infinity. To the right of 0, you have positive infinity. So because of this and a greater than or equal to sign, this point will be a closed point. Closed point. So next up, we need to find numbers between 6 and 0 and plug it into our original inequality to see the answers we'll get. So let's say we pick a number 7. So we know that 7 here, let's write our inequality here again. It's minus 6 greater than or equal to 0. So we know that if we pick a number 7, so 7 here is a positive number, okay? And then 7 minus 6 is 1, which is another positive number. We know that positive number times a positive number give you a positive number every time. So all numbers from 6 to positive infinity will give you a positive number for this inequality, and it's satisfied inequality. Okay, so next up, pick a number between 0 and 6. So let's pick a number 5. So if you pick a number 5, let's clean up the sign that we've done before. So if you pick a number 5, 5 here is a positive number, so positive. 5 minus 6 will be a negative number. Now we know that a positive number times a negative number will give us a negative number. Okay, so that does not satisfy the inequality. So write a negative number here. And the next up, for the next interval, we have a 0 to negative infinity. So this means that for 0, let's say we pick a value of -1 between 0 to negative infinity. So let's clean up this sign still. So this is -1. If you have -1, that's a negative number, times -1 minus -6 is negative. So we know that negative times negative will give us a positive number. Okay, so that means it's a positive number. Now for the points that satisfy our inequality, we pick here to here and here to here. So the domain of this function, the domain of this function will be equal to, between here to here, we have a negative infinity, comma, 0. And because this is a closed point, we have our square bracket. Union of, from 6, this is a closed point, so this is 6, comma, 0, positive infinity. Positive infinity. Okay, so that's simply how to find the polynomials with roots. So let's do another example. Okay, so for the next set of examples, we have fraction-related functions. So before you start solving fraction-related functions, there's one thing I want you to know. For the numerator of a fraction and the denominator of a fraction, so you can have fractions of 2 over 5, or you can have fractions of 0 over 10, or you can have fractions of 5 over 4, or minus 5 over 6. But you cannot have fractions that are 2 over 0 or 10 over 0. These fractions are undefined. And we know that for a domain to happen, the domain needs to happen for defined regions. Okay. So in this case, anytime you're solving a fraction function, you need to make sure that the denominator of the fraction is not equal to 0. So most times you ignore the numerator, except the numerator has a square root. So you need to make sure that the denominator is not equal to 0. So in this case, x squared minus plus 9 is not equal to 0, should not be equal to 0. Now we know that x squared going to the other side, so x squared is not equal to minus 9. So x squared not equal to minus 9 is not a possibility, because if we take the square root of both sides, square root of minus 9, this cannot happen. Square root of minus 9 should not happen. So this means that this doesn't stand. Okay, there's no factor of x that will be giving you minus 9, x squared that will be giving you minus 9. This means that for this fraction, the domain is equal to all real numbers. Or you can write it in interval notation form of saying negative infinity to positive infinity. Okay, so let's pick another example. So for this example, we just pick the denominator and solve for it. Okay, so we must make sure that 4x minus x squared is not equal to 0. So factorizing this, you have x open bracket 4 minus x has to not equal to 0. So first of all, we need to make sure that x is not equal to 0 and 4. So if you solve this, these are the two terms you get. So x should not be equal to 0 and 4. So to write this in interval notation form, let's say we have 0 here and then 4 here. So this is open bracket, open circle, or open points. Open points. Let's draw it properly. So this is point 0, and these are open points, and then this is point 4, and these are open points. Okay, so positive infinity and then negative infinity. For these sort of answers, it means that x should be equal to every other answer apart from 0 and 4. So our domain will be equal to these points, this region, and this region. So to write it in interval notation form, we could say the domain of our function is negative infinity to 0, but not including 0. Okay, so we've gotten this region down, and then for this region, we know that union of 0, not including 0, to 4, not including 4. Union of between 4 and positive infinity. So 4 and positive infinity. So that's how to get the domain of fractions. Okay. So next up. Okay, so still on domain of fractions, you can pause the video and try to find the domain of this fraction. So like we did before, our interest is on denominator. Okay, so we knew that 3x plus 5 cannot be equal to 0. So this simply means that x is equal to, if we solve this and make x a vector formula, x should not be equal to 5 over 3 minus 5 over 3. So the point of interest on my number line is minus 5 over 3. So this is my number line, and then I have an open point of minus 5 over 3. And then to the left of it is negative infinity. To the right of it is positive infinity. So the domain of my function is everything from here to here, except minus 5 over 3. And then everything from here to here, except minus 5 over 3. So we can write the domain of this function as equal to, this region is negative infinity, comma, 5 over 3. You have a parenthesis, union of from negative over 5 over 3. This is negative 5 over 3, of course. So this is negative 5 over 3, comma, positive infinity. So let's take another example. So for fractions with roots examples, fractions for the denominators, we know that the denominators must not be equal to 0. But if we say the denominator must not be equal to 0, if you have a square root, denominator must not be less than 0 too. Okay, so for just normal fractions, it was permitted that our denominator can be 1 over negative 3 or 1 over negative 4. But because of the square roots, we cannot have 1 over square root of negative 3. This is not defined. This is not defined. Okay, but this is defined. So in this case, we need to make sure that our number is greater than 0. So we know that for our 9 minus x squared, for the number inside our square root, it cannot be equal to 0 because square root of 0 will be 0 and this fraction will be undefined. So you know that this number has to be greater than 0. Okay. So from here now we know that we can simplify this function, this quadratic polynomial. Okay. So simplifying this, we could say this is 3 minus x. Okay, and then 3 plus x is greater than or equal to 0. So we need to get points that we need to use on our number line. So for the first point, we pick the first bracket, and then this negative x is equal to negative 3, or x is equal to negative 3. So this means that x is equal to 3 or negative 3. Next up, we bring our number line into the fold. So this is negative infinity, and then this positive infinity. So between here, we have negative 3 here, and then 3 here. So looking at our inequality sign, this is a greater than sign. So this is the open point, and this is the open point. So next up, we pick numbers between 3 and positive infinity. Okay, so let's bring out our inequality here. So we had 3 minus x, and then we have 3 plus x greater than 0. So between 3 and positive infinity, if we pick a number, say we pick 4, this will be 3 times minus 4, which is a negative number, which is minus 1, negative number. So this is 3 plus 4, which is a positive number. Okay, so minus times plus will give you a negative number. So everything from here on will give you a negative number. And then on for this one, between minus 3 and 3, if we pick a number, say 0, let's clean the signs we assigned before. So if we pick a number of 0, so 3 minus 0 is a positive number, which is 3. And then 3 plus 0 is 3, which is a positive number. So that means that this is positive number stuff. Okay. And then for the next interval, between negative 3 to negative infinity. Okay. So for this now, we have negative 3 is, let's say we pick negative 4. Okay. So 3 minus 4 is a positive number. And then in this case, 3 minus 4 is a negative number. Okay. So a positive number times a negative number will give you a negative number. So any point from here to here will give you a negative number. There's a simpler way of doing this, okay, of this interval stuff. Now, if you notice that the powers of the two brackets multiplying each other, or two terms, factors multiplying each other, is in the odds. Okay, so 1 is an odd number. So if you get the first one, the other one would interchange to a positive, and the other one will be negative. If you get this one to be a positive, this one will be negative, and this is a positive. But if these were even numbers, this would be positive, positive, positive. Okay, so in this case, we've already done it. So our answer to this problem, so the domain lies within these 2 points. Okay, so the domain of our function is equal to negative 3, but negative 3 not inclusive, so we had a parenthesis, comma 3, we have a parenthesis. Okay, so this is the domain of this function. So let's quickly take another example. Okay, so you can pause the video and try to solve this one out yourself. So like before, our point of interest is the denominator, okay? But in this case, we have a square root for our numerator. So we cannot have numbers that are less than 0, okay? So we know that for numerators, we can have 0/4. So we can have numbers that is equal to 0 for a numerator. Okay. So to solve for our denominator first, we have x minus 5 has to be greater than 0. Then the point of interest here is x greater than 5. Okay. Or x equal to 5. X equals to 5. Point of interest, x equals to 5. So on our number line, we have 5, we have negative infinity here, and positive infinity. So to the right of our number line, say if we pick a number 6. So 6 minus 5 is 1, which is a positive number, and it satisfies our inequality. So there is a positive number. This is an open point. So if you pick a number less than 5, say 2. 2 minus 5 is negative 3, and that doesn't satisfy our inequality. So it is here. So the domain of our denominator, so I'll call it d of d. Okay, domain of our denominator is between 5 and positive infinity. So next up, we need to solve for domain of our numerator. Okay, so for domain of our numerator, we knew that 1 minus x has to be greater than or equal to 0. Okay, because it is permitted for our numerator to be a 0 number, but we cannot have a negative infinity for our numerator, negative number for numerator now. So in this case, point of interest is 1 minus x equal to 0. And then we knew that moving this over to this side, x is equal to 1. So the number line would be of this form. So you have 1, and then you have negative infinity, positive infinity here. So the number to the right of this place would be, say, 3. So we know that 1 minus 3 is a negative number. Okay, so this is a negative number. And then to the left of it, we have minus, let's say minus 1. Okay, so 1 minus minus 1 is a positive number, and it satisfies this inequality. So this is here. So our domain for our numerator is this point. So domain for numerator dn is negative infinity, this is a closed point, 1 up to 1. Okay, so to get the domain of our function, so the domain of our function would simply be saying domain of our numerator intersecting the domain of our denominator. Okay, so the intersect between these two is nothing. Okay, so this is nothing. Like, the answer is a null set. Okay, the intersect is simply numbers that exist here and here. Okay, so if you check this, the domain of the numerator, if you had set it, you have 1, 0, minus 1, and then up to negative infinity. But the domain of our denominator is 5, 6, 7, positive infinity. So if you check these two sets, there's nothing in common. So the answer of our fraction, domain of our fraction, is null or an empty set. Okay, so that's it for how to find the domain of functions. So if you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching.